So in the previous class, we were discussing about the solution of differential equations. Okay, using Laplace method, then we understood some standard signals, meaning of standard signals, and the advantage of understanding representing the standard signal. Then we took one simple example of spring and this spring and damper example. So we assumed m equal to 0, then we solved it for x of t. Okay. So this convolution part, as of now, you can skip it. No need to worry about this. It's not a control system thing. But once you study convolution in signals and system, I'll get back to this concept again and explain you clearly about the relation between convolution and multiplication in Laplace domain. So we understood that f of s can take any shape. The force or the input signal can take any shape, and precise mathematics will give us x of t for a given f of t. So for time being, we considered f of s to be a step function similar to the signal of DC voltage. Then we solve for x of t. So when you solve for x of t and plot it on a time scale, this is how we can represent both input and output together. Okay, this is f of t input, and this is approximate shape of a output. I am repeating because approximate I am drawing because of the only reason we can make calculation. Let us not waste time on this because we are again studying this in a third unit. So any questions pertaining to this you can upload in the sheet whichever I have shared, or you can ask in the next class. So I assume till now everything is clear. So next I will start with just one question again to ignite your thinking. So here I have applied Laplace transform to solve the differential equation of a spring and damper with m equal to 0. I'll repeat the question. Here we have applied Laplace transform to solve the differential equation of a spring and damper system with m equal to 0. So my question is, can we solve the same thing? I mean, can we obtain the expression for x of t, or not exactly like this, some expression of x of t using Fourier transform? Can we obtain the expression for output for this particular system using Fourier transform? So please think on this. If anybody has any answer, can give it with some justification. I have applied Laplace transform and got x of t equal to something which I can plot and represent. So can I do the same thing using Fourier transform? Is it possible? Don't think of this kind of steps involved in solving and all. Just the answer. Is it possible with Fourier transform? I just want to know what you have understood with respect to Fourier transform. Okay. So think on this, then you can enlighten yourself with the knowledge of transforms. It's a very good mathematics actually. So I leave the question to yourself and think, can we solve a simplest differential equation of first order using Fourier transform? Yes or no? If yes, how? If no, why? That should be your answers. So we'll move on to the next part now. So we are almost about to finish the conceptual discussions about control system, and we will quickly move on to solving numericals and all those things. So I'll share another screen for you to start with. So next we'll consider another kind of numerical. Okay, a similar numerical, but solving it in a different way. So now onwards, we will come to the actual examples of mathematical modeling. So you might have seen the video which I was playing, I just went outside. In that, so many terminologies he had used, that quadcopter wala. And in that, one of the terminology was about mathematical modeling. I hope you listen to it. So now onwards, whatever I had discussed till now is a background of physics and maths, and now onwards we will start that mathematical modeling. So I hope I have explained mathematical modeling, but just to give a brief introduction, simplest way of understanding mathematical modeling is to express a physical system in terms of mathematics, okay, which governs the fundamental laws. So if you want to represent a mathematical equation for mass, or if you want to develop mathematical modeling of mass, you can write F equals to m into a, force equal to mass into acceleration. So that is the equation which governs the fundamental laws. You cannot randomly write mass in terms of any random equation. That's not a mathematical modeling, so please remember. So coming to this mathematical modeling of this system, though we have done, I'll just start with another approach. We have again mass spring damper, we have force, we have x of t, and this is a intermediate step. So what I'm writing as equivalent diagram. Different text will call it in a different way, but I refer it as an equivalent diagram. So when I ask mathematical modeling of a system, writing a differential equation often, writing a differential equation directly often makes it very difficult. So the intermediate approach is to draw the equivalent diagram and then go for the differential equation. So what is that intermediate step? Let us look into that. So we draw an equivalent diagram and we represent force as an input by showing this symbol. Okay. Then we represent all the elements of the mechanical system in this way. Then we call, let us write the symbols of the system, mbk. Then this particular node is referred as x of t. Okay, x of t, and it is called as a node. Okay, so this is a conventional way of drawing equivalent diagram. So conventional means it should make you the things easier. So there is no other method which exists that can make the things simpler than this. So that's why I'm referring this. I mean, most of the people refer this method. I mean, don't create more doubts on this diagram, not required. You just understand the procedure. So how it goes. So input is represented with this
Excuse me,
symbol.
sir.
Yeah,
Why parallel, sir? Why not in series?
that's right. I will explain. So what this diagram explains, input is f of t, and this force is getting distributed to all the elements like this. Okay, so that's why all these are parallel. I hope I have answered your question. Okay, force is getting distributed to all the elements, so that's why it is parallel. You can imagine equivalently a current source connected to RLC elements. Okay, so just a scenario I'm telling. It is not same as RLC circuit, parallel RLC circuit, but to understand a scenario, since the force is getting distributed uniformly on all three elements, we can, without any doubt or without loss of the generality, we can represent them in parallel. And this node is x of t because it represents the output. So wherever we have a output like displacement, okay, without any doubt we can bring them or denote them at a node. Okay, at a node. So if you ask why like this, why not here, why not here as x of t, why not here as x of t? Okay, so representing x of t at this node indicates that all three elements essentially have got displaced by equal amount of distance. Okay, I repeat. You may ask me a question, why not x of t here, why not x of t here? Okay, that is not a conventional way. So we cannot write x of t here, leave it. And coming to little conceptual meaning, you may also ask why x of t not here, why x of t is not here, why not here? So the thing is, since all the elements, the free end of spring, the free end of damper, and the mass are getting displaced with equal distance because of this force. So without any doubt, we can represent this as a node in an equivalent diagram. Okay, I hope it is clear for everyone. So this is input, this is output now, and these are the elements of the system. So now we can write the differential equation for the equivalent diagram, which is same as that of the previous case. I mean, previously we already have written the differential equation for this, but some additional I mean, wordings I will use. I'll write at node x of t. So the system dynamics at node x of t. The meaning of writing at node of x of t means the dynamics of the system at node x of t. So f of t equals to, at node x of t, f of t is input, equals to the force distributed on all the three elements. That is f subscript m plus f subscript b plus f subscript k. So fm of t, fb of t, fk of t, I have already told. Please try to maintain the notes. You can refer all these things back again whenever required. So without any doubt, it is md square x by dt square plus b dx by dt plus k into x. So whenever I write x, it means x of t only. X is a function of time. So this is the equation. So now the ultimate objective of mathematical modeling is to write its transfer function. Once you write the transfer function of a given system by converting the differential equations into Laplace transform, that will be your mathematical model. Okay. So what was the Laplace transform for previous system? It is x of s by f of s equals to 1 divided by ms square plus ps plus k. I want everyone to write this, though it looks simple. I request people to write this. I'll give 1 minute. Please write the transfer function for previous example of mass spring damper. So writing things again and again makes like things to remember very quickly. If anybody is not able to get the transfer function, you can stop and ask me your query. So I'll try to spend more time on simplest things so that when we encounter any complicated things, my job will be easy. Anybody is facing difficulty? Siri M, are you able to derive the transfer function?
Yes, sir.
You got the transfer function, okay. Trideep,
Yes, sir.
you got the transfer function. Fine, that's fine. So we'll move ahead with another type of numerical. So consider this mass spring damper, but with one additional spring and another mass block. So let us write it as m1, m2, k1, k2, and 1b. Then f of t, please, everyone, please draw this diagram. K1, K2, M1, M2, f of t, and b. I will hold on for 10-15 seconds. Ganesh, is it clearly visible?
Yes, sir. Yes, sir.
Okay. So this is f of t. This t is not written properly. Okay, fine. So now you can imagine a scenario of a locomotive or a railway or a train. So this represents one compartment, I mean, or one bogie, and this represents another bogie, which are connected to some spring or a shock absorber. Fine. Then uh, the question is, there is only one input. There is only one input, that is force f of t. So the question is whether this force f of t has any impact on m2. Whether this force f of t has any impact on m2. Just think on that, because Anyhow, we are directly applying force to M1. Without any doubt, this will have a displacement. But to move one step ahead, to think one step ahead, does M2 has any impact of force? So it is obvious M2 will also have the effect of force F of T input, because when M1 is moving, the shock absorber or the spring will also get displaced. So now the spring K2 has both the ends as free to move. Okay, both are free ends. So when M1 moves, obviously the first or the end which is connected to M1 will move. And since this whole element is connected, so if this free end is moving, this will impact the other end also to move. Okay, so just I'm using the word movement. With we no need to bother about the direction as of now. Don't worry about the direction. So when K2 moves, M2 will also move. So if I push this, M1 will move, then K2 will have its effect. Because of that, M2 will have effect. So this is a sequential effect, cause and effect scenario. So now I will move one step ahead and ask the question that K1, B and M1. If you ignore this K2 and M2 part, if you ignore K2 and M2 part, K1, B and M1 is nothing but a previous system, same as MBK system. So without any doubt, we can represent there exists one impact of this force, which it can be x of t. Okay, because of this force on M1 K1B, there is a output or there is a response which can be written as x of t. Fine. So once we write x of t, another question is how many displacements do you expect? How many such displacements do you expect?
Two.
Two, right? X1 and X2. Yes. So x of t, I will write it as x1 of t, and I will write m2.
X2.
That-
X2 of T.
yeah, the displacement of m2 as x2 of t. So this is a crucial part. It looks simple, but this is a very crucial part. Identifying the outputs of the system. Think in general. Don't think with respect to this numerical or example. In a given system, identifying the number of outputs for a given input is very crucial. Okay, because then only you can understand or mathematically define in an exact way that system is actually. What I mean to say is, if you are not able to identify the number of outputs, you may end up with a wrong mathematical model. You will end up with a wrong mathematical model. So you should be capable of knowing how many outputs exist for the given input. It is as good as saying how does your input is impacting on your system. So if your brain is if you consider a brain as a system and you want to get its mathematical model, one should know how many outputs exist in your brain, right? Then only you can arrive at exact mathematical model. But if you ignore, say, some inputs and I want to consider only this, if you ignore some outputs and if you restrict to smaller number of outputs, then your mathematical model will go very wrongly. And if you want to put that in robot's brain, then you will end up with a mental robot. So that's how the scenario is. So here we have two outputs, x1 and x2. So now coming to the mathematical model, how to write the differential equation. So as I said, it is quite difficult to write a differential equation just by looking at this diagram. So that's why let us follow this conventional method. I will draw the equivalent diagram. So while drawing equivalent diagram, we we can make one conclusion from the previous example that a node represents an output, because x of t was a node in the previous diagram. So one conclusion we can make is a node always represents the output parameter. So how many outputs we have? We have two outputs. So without any doubts, just draw two nodes and name them as x1 of t and x2 of t. So first conclusion is there exist two nodes without any doubt. Look at the diagram. I will explain one by one. Just see the equivalent diagram and see what is going on. Try to understand what is going on. So question yourself, why K2 is like that? Why it is not parallel to M2? Why X1 and X2 to be connected? Why all elements are not in parallel? Why they are not in series? That's also a good question you can ask yourself. Why K2 M2 are not in series? So I'll give 2 minutes to think yourself looking at the equivalent diagram. Let us see how. If you feel the diagram can be different, you draw yourself. Then understand my explanation or listen to my explanation and then compare whether your equivalent diagram obeys the physical law. So take 2 minutes of time to think about this diagram, or if you want to draw a different diagram, you can draw it. And I'll proceed with the explanation.
Excuse me, sir. Sir, in this equivalent diagram, I just wanted to know
Mm,
how is the direction of f of t? Uh,
okay, I'll answer your question. Anybody else has any other question? You can ask now itself. I'll consider all together.
Sir,
Yeah.
f of t, we represent it as a current source, right? Like
That
just for an, is it
yes.
always represented in a current source, or we can use voltage source also?
Okay, I'll take this question and answer soon. Okay, I hope everyone have finished yourself and no more doubts. Fine. So I hope parallelly we were able to answer yourself about the questions I had asked. Coming to the first question, who had asked that question? Come again, please.
it's me, sir, Abdul.
Yeah, yeah. What? Sorry, I forgot.
Yeah,
I got.
how do you decide the direction of f
Yes,
of
yes,
t?
yes. Sorry. Fine. So the direction of f of t is unknown at this point of time. Okay. Why? Because we consider this that as input signal. It can take any shape, any direction. Okay. Because see, if you take force f of t as a sinusoidal, for example, can you imagine a sinusoidal signal? It starts with a 0 newtons, go to plus 5 newtons, then come to 0 newton, then come to minus 5 newton. Just a scenario. So sinusoidal signal, in the sense you can apply force in a sinusoidal way also, right? But what you observe at the output side is the behavior of the system for such input. For such input. So until and unless we are going for a precise analysis for a particular application where the direction is very important, till then we assume f of t as just a input signal of any shape in matter of the direction. Okay, so our ultimate objective is just to get the transfer function, and in transfer function no way we can represent the direction of any signal. It is just x of s by f of s. We never say x of s in a downward direction, f of s is in downward direction. There is nothing like different transfer functions for different inputs. Fine. In the sense, we never write x of s by f of s. This equation is governed only for downward direction. We never write x of s by f of s. This equation is governed only in clockwise direction. No, that is not the way of representing transfer function. Transfer function is just x of s by f of s. In matter of direction, in matter of the direction of output. Got it? Mathematical modeling will have only mathematics, no direction. And next, coming to the second question, it was asked about can we consider it as voltage source? Okay, we can consider without any doubt. We can consider it as voltage source, but not here. We'll come to that part soon in the next week. Input source can be anything, whether it is current or voltage. And force also similarly, we can refer it as a current source or a voltage source. So there's no issue with that. Okay, next coming to this diagram equivalently, I will explain it very quickly. We have f of t as an input. So this impact of force is balanced at first by these three elements m1, k1 and b. So since it is uniformly applied and its immediate impact is on these three elements, x1 is represented as the first node and the x1 is impact of force on these three elements, so they come in parallel. Okay, then k2 is because of the effect of force on x1 and ext or m1 and m2. So when we consider k2, the displacement of k2 is now referred as relative displacement. Okay, it's now referred as a relative displacement. Therefore, the relative displacement, as I said earlier, is the difference between these two displacements. Okay, is the difference between these two displacements. And when we consider the direction precisely, then you can ask so many questions to me, like if it moves in this direction, if it is moving in this direction, if x1 is moving in this direction, x2 is moving in this direction. There are like many possibilities. Okay, many possibilities. In some cases, you may need to add up. Okay, in some cases, you may need to subtract. So, but let us not bother about the directions as of now. We just assume that the relative displacement of k2 is difference between x1 and x2. Okay, even the usage of word difference is not a right word. We just refer the displacement of k2 is a relative displacement. That's enough. But how to represent k2 in the equivalent diagram? Obviously between these two nodes. Obviously between these two nodes. Okay. Then coming to m2, the movement of m2 is governed only by x2. I mean, whatever the force exerted because of f of t on m2 is responding by getting displaced as x2. That's why x2 will have a m2 element as a parallel element. Fine. So now, what happens if I represent m2 here, that is between x1 and x2? There won't be any meaning, right? There won't be any meaning if I write m2 just in series with k2. You cannot interpret it with the physics. Okay, so that's not a right way. So series and parallel combination, you should understand the physics and then you need to write. Okay, so moving to the differential equations part. Okay, it's already time. I will wind up and we'll continue the differential equation part in the next class.